Here's an interesting looking U tube where one end is closed and this whole grey color thing is mercury. So there's a little bunch of bubble of air trapped here at a certain pressure. And the other end is open to the atmosphere. That's what they say here in the questions. I'm going to underline that. Open to the atmosphere, but you kind of stick a piston inside there. So there's a piston right here with a certain mass and a cross-section area. So density of mercury is given to us. That's our rho. And atmospheric pressure, let's call this P11, is that. So I'm going to add atmospheric pressure to our diagram here. Atmospheric pressure happens when there is a pipe that is open to air. So that will be on the left side actually. Don't forget, air is also pressing down on you, a certain atmospheric pressure. Okay, what we need to find out? What's the height of the column here? Okay, whenever you see any kind of U tube, V tube, W tube, or the tube that is like, go down and come up one like this, you think of the first point, which is that the pressure on the left equals to pressure on the right if the liquid is not moving or oscillating, it's just steady, same height. So let's write that down. The first idea, pressure on the left equals to pressure on the right. Now you might say, Miss, why don't we say force on the left equals to force on the right? You could start with that, but the problem is we don't know the area of the cylinder on this side. We only know the area on this side. So we're going to do our pressure one here, okay? So pressure on the left. Who is pressing down on the left? We've got atmospheric pressure. So let's write that down. Atmospheric pressure. Who else? Oh, piston. The piston is heavy. It has some kind of weight, mg, that is pulling it down. And therefore, the piston will press down on the liquid. So let's write here P due to piston. Thanks to the piston, we also have a pressure. Then, if we draw this at the middle line, we say, how about this part, miss? Don't we need to add pressure due to mercury on this side? It turns out that the pressure is the same at this level on the left and on the right. So you can consider that these two will cancel out. Pressure, mercury, pressure, mercury. No need to write lah. So on your reference point, if it's all mercury down there, you don't need to write that one. Because on both sides, it will cancel out. So we're not going to write that. We're just going to put equal. And on the right, we add everything. So need to write mercury or not? No need lah. They will cancel out left and right. So we take our reference line. Above the line, we add. Okay. Then we have pressure due to the water mercury column. The one with height h. And then lastly, pressure due to the air trapped in that little corner. Now we substitute all the values inside there. So atmospheric pressure is given to us 1.01 times 10 to the 5. Actually, no. Let's rewrite this thing. It's not too long, is it? P11. Pressure due to piston. You only give mass, Oh, okay. I know. So pressure is force per unit area. This piston is heavy. So that will be mg, which is the weight per unit area. So later must put here, okay, mg per unit area. And then mercury. Since this is a column of liquid, then we will want to use our rho gh. And lastly, pressure of air. Okay, we are now ready to write the whole thing out. So let's do just that. P11, 1.01 times 10 to the 5 plus, how heavy is the piston? 5 kg times 9.81, because that's the weight per unit area. So 5 times 10 negative 4. Okay. Equals to, on the other side, we have density of mercury. Oh, it's going to be a very long line of calculation. 113600000 9.81 and h, no space ready, plus the pressure of the trapped air. 5 times 10 to the 4. No, it looks a bit crowded, but when you can calculate step by step, but you should be able to eventually find h. Let's do some calculation. And I would get 1.1176, I guess, meters. That would be my answer if I did everything in one step. So for the answers, I think we'll need to see, okay, 2SF, in cm. Okay. So this is about 1.76 cm. And we round it to 2SF. That would be 110. So best choice would be D. So that's how we can find all kinds of pressure-related problems related to any curved tubes, V tube, U tube. Just remember the key idea that if this object, this whole liquid is not moving around, it's steady, pressure on the left side of the wing equals the pressure on the right side of the wing. But that's all for this video. I hope that was helpful. I'll see you in the next one.